Hello friends, welcome back to my channel Maths by Samit Deshmukh. In the last video, we have completed first 10 examples from first part of miscellaneous exercise, which are nothing but multiple choice question. Now we are starting second part of miscellaneous exercise. In the second part, we have to solve the following. So see, in the question number first, what we have to do, we have to identify the random variable is either discrete or continuous. Again, let us revise once again the definition of discrete random variable and continuous random variable. When we can say that value of random variable is discrete if its value is countable or infinitely countable. And when we can say that random variable is continuous if its value is infinitely uncountable, means if it takes the values in some interval on a real number line, and on a real number line we know that in between any two real number infinite real numbers are there, and that's why it is not possible to count it, and such random variable is called as what? Continuous. Means in short, if the values are countable, it is called as discrete. If the values are uncountable, at that time it is called as what? Continuous. If the random variable is continuous, at that time we can say that it is measurable. Measurable means it takes the values in some particular interval on a real number line. This part already we have discussed in detail. Now some examples are given to us, and we have to identify whether the random variable is discrete or continuous. If the random variable is discrete, then list the possible values of x. See the first example. अभी हमें क्या करना है? पहचानना है random variable discrete है या continuous है. अगर countable है तो discrete, अगर measurable है तो फिर इसे हम बोलेंगे continuous. See in the first example, an economist is interested in the number of unemployed graduates in the town of population 1 lakh. Means what is the population of the town? Population of town is equals to 1 lakh. It is given to us. Now our random variable shows what it means an economist is interested in the number of unemployed graduates in the town. So that's why we are defining the random variable as, let x denotes number of unemployed graduates in the town. So therefore possible values of x are, now total population of the town is what? 1 lakh. 1 लाख आदमी है टाउन में. अब उसमें से ढूंढना है कि नंबर ऑफ अनग्रेजुएट. सो एक पॉसिबिलिटी है कि सबके सब 1 लाख ग्रेजुएट हो सकते हैं. दैट इज वन पॉसिबिलिटी. मीन्स नंबर ऑफ unemployed graduates, and unemployed means they does not have as any employment, so may be possible that such number will be equal to 0. या तो हो सकता है कि 1 पर्सन हो सकता है, या तो 2 हो सकते हैं, या तो 3 हो सकते हैं, या तो फिर 1 लाख टोटल 1 लाख भी हो सकते हैं. So these are possible values of x, and here we can observe that the values of x are countable. That's why we can say that x is discrete random variable. So here, and x is discrete random variable, and its values are from 0 to 1 lakh. So now observe the next example. In the second example, amount of syrup prescribed by physician. So here we will denote, or we will suppose that x is a random variable which denotes amount of syrup prescribed by a physician. Now the amount of syrup prescribed by the physician is takes the values in some interval, या तो फिर 2 से लेके 3 ml तक, or in between any two real number. How many real numbers are there? Infinitely many real numbers are there. So that's why here we can say that x is continuous random variable since its value is measurable, that is infinitely uncountable. Now see the example number 3rd. In this example, a person on a high protein diet is interested gain of weight in a week. So x denotes what? Gain of a weight in a week. Suppose that his weight is say 50 kilogram, and in a week the gain will be 2 kilogram, means it becomes what? 52. Let us consider one example. Means here x takes the values in between what? 50 and 52. In between 50 and 52, how many numbers are there? Infinitely many numbers are there. That's why we can say that here values of x are infinitely uncountable, and since values of x are infinitely uncountable, that's why we can say that x is what? Continuous random variable. Hope you are getting it. So now in the next example 4, 20 white rats are available for an experiment. 12 rats are male. A scientist randomly select 5 rats. The number of female rats selected on a specific day, that we have to find out here. Means x is what? Random variable, which shows what? Number of female rats selected. So here total number of rats are 20, it is given to us. How many number of male rats are there? 12 rats are male, it is given to us. Means remaining 8, total 20 rats are there, out of which 12 are male, means remaining 8 are what? Female rat. So 5 rats are selected randomly. So what x denote the number of female rat. Suppose that the value of female rat selected may be 0, maybe 1, maybe 2, maybe 3, maybe 4, or all the 5 rats selected randomly may be female. Means here x takes the values. What are the values of x? 0, 1, 2, 3, 4, 5. Means here total 6 values are getting, and since the value of x is countable, that's why we can say that x is, since values of x are countable, therefore x is discrete random variable. Now observe the example number 5th. A highway safety group is interested in studying speed in km/h of a car at a checkpost. Now at some checkpost, let us suppose that the speed of car is in between, say it takes the values in some interval, suppose that 70 to 80, but in between 70 and 80 infinitely many numbers are there, and we know that in between any two real number infinitely many real numbers are there. Means here value of x is what? Uncountable, infinite also and uncountable also. So that's why we can say that x is what? Continuous random variable, where x denote what? Speed of a car in km/h, and here x takes the values in some interval. That's why we can say that value of x is infinite and uncountable, and if the value of x is infinitely uncountable, we can conclude that x is what? Continuous random variable. In this way we have completed 5 examples from question number 1st of second part of this miscellaneous exercise. Now see the question number 2. In this question number 2, the probability distribution of discrete random variable is given to us, and using this condition we have to determine first the value of k. Here k is one unknown value, and later on we have to find out these 3 values also. First we are trying to find out value of k using the condition that this is probability distribution of x. If it is probability distribution, means definitely it will be a probability mass function also. So x, so here p of x is equal to x is probability mass function. Since it is a probability mass function, that's why we can conclude that sum of all probabilities will be equals to what? 1. So using this condition we are trying to find out our first required value k. So means here how many values of probabilities are given to us? 6. Means we can say that p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5 plus p of 6 will be equals to 1. Means sum of all these probabilities 1. Remaining part is just to substitute the value. P of 1 is k, p of 2 is 2k, p of 3 is 3k, p of 4 is 4k, p of 5 is 5k if you observe the condition, and p of 6 will be equal to 6k is equal to 1. Now collect the terms of k. So k plus 2k is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. So 21k is equals to 1, which implies that k is equals to 1 divided by 21, 1 upon 21. In this way we have got our first required value k. Now let us try to find out second required value. So here we have completed first part. In the second part, first we have to find out value of value of P of X less than or equals to 4. Now check that which value of random variable are less than or equal to 4. Less than or equal to 4 means what? 4, 3, 2, 1. These are the values of X which satisfies this condition, means these are the values of X which are less than or equal to 4. So means to find out here this value, we have to take the addition of these 4 probability, means which probability? P of 1 plus P of 2 plus P of 3 plus P of 4. Now substitute the values. So P of 1 is equal to K, P of 2 is equal to 2K, P of 3 is equal to 3K, and P of 4 is equal to 4K. If we are collecting all the terms of K, so K plus 2K is 3K, 3 plus 3 is 6, 6 plus 4 is 10, 10K. So which is equal to 10, keep it as it is. I am replacing K by its value 1 by 21. 1 by 21. So see what we'll get. 10 into 1 will be 10, 10 upon 21. So 10 upon 21 will be our required value. Now see the second part. In this second part we have to find out value of P of X greater than 2 and less than 4. How many values of X are there which are in between 2 and 4? In between 2 and 4 only one value of X is there, that is 3, means its value is equal to P of 3, and P of 3 is how much? 3K. So 3, keep it as it is. K I am replacing by its value 1 by 21. So here we can observe that both the numbers are divisible by 3. 3 ones are 3 sevens are, means what result we are getting? 1 by 7. 1 by 7 is our next required value. Lastly, we are finding P of X greater than or equals to 3. Now check how many values of random variable are there which are greater than or equal to 3. Means 3 is also included, and greater than 3 means 3, 4, 5, 6. Means its value is equal to P of 3 plus P of 4 plus P of 5 plus P of 6. So which is equal to, what is P of 3? 3K, P of 4 is 4K, P of 5 is 5K, and P of 6 will be equal to 6K. So which is equal to, now take the addition, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 3 is 18, 18K. So 18, keep it as it is, just simply replace K by its value, where its value is 1 by 21. Again here we can observe that both the numbers are divisible by 3. 3 6s are and 3 sevens are. So what result we are getting? 6 by 7. 6 by 7 is the value of P of X greater than or equals to 3. In this way we have got our third required value. Now see the question number 3. In this question, the following is the probability distribution of X, means probability distribution of random variable X is given to us. Using this, we have to find out these 4 values. So let us try to find out first value using this probability distribution. So our first value is what? Probability that X is positive is equal to. So X is positive means, can I say that its value is equal to 1, 2 and 3, means its value is equal to P of 1 plus P of 2 plus P of 3, because only 3 values of random variables are there which are what? Positive. So that's why we can say that our required probability is P of 1 plus P of 2 plus P of 3 is equal to P of 1. Here we can observe that 0.25, P of 2 is 0.15 plus P of 3 is 0.1. So which is equal to, here 0.25 plus 0.15 is 0.440, means 0.4. 40 can be considered at what? 0.4. 0.4 plus 0.1 is 0.5, means 0.5, or you can say that 0.50. In this way we have got first required value. Now we are finding second probability that X is non-negative is equals to. Now value of X is non-negative means, can I say that value is either equal to 0 and greater than 0, because we are deleting which part? Negative part we are deleting. So if we are excluding this negative number, means remaining are what? Non-negative, means non-negative number is either 0 or what? Greater than 0. So this is our required probability, and in this case how many values of X satisfies this condition? 4. So P of 0, again 1, then 2, and lastly what? 3. These are the 4 values of X which are non-negative. So that's why we can say that addition of these 4 probability will be our required probability. Now remaining part is just to substitute the value. P of 0 is equal to 0.20, P of 1 is equals to 0.25, P of 2 is equals to 0.15, and P of 3 is equals to 0.1. Now we are taking addition, so 0.20, 0.20 plus 0.25 is 0.45, 0.45 plus 0.15 is 0.60, 0.60 plus 0.1 will be equals to 0.70, means 0.70 will be our second required probability. Now let us try to solve the third example. In the third example, we have to find out probability that x is odd. X is odd. Now observe the values of x which are odd. First value is -3, then next value is -1, so P of -1, next value is +1, so consider here P of +1, and lastly P of 3. So these are the values of x which are what? Odd, if you will observe the given probability distribution. Now substitute the values. Probability of -3 will be equals to 0.05, probability of -1 will be equal to 0.15, probability of 1 will be equals to, observe the value, 0.25, and probability of 3 will be equals to 0.1. So which is equal to 0.05 plus 0.15 is 0.20, 0.20 plus 0.25 is 0.45, 0.45 plus 0.1 will be equals to 0.55. Lastly, let us try to find out last required value, that is probability that x is even. So now check how many values of x are there which are even. First value of x which is even is -2. Even 0 can be included in even. Then what? P of 2. Only 3 numbers are there which are even number, if you'll observe the given probability distribution very carefully. Now remaining part is just to substitute their probability. Probability of -2 will be equal to 0.10, probability of 0 will be equals to 0.20, and probability of 2 is equal to 0.15. So check whether values are correctly substituted. Yes, 0.10, then 0.20, and lastly 0.15. Remaining part is just to take the addition. 0.10 plus 0.20 is 0.30, 0.30 plus 0.15 will be 0.45. In this way we have got, or we have completed all the 4 examples in this question number 3. Now see the question number 4. In this question, the probability mass function of a random variable x is given as. So observe how it is defined. P of x is equal to 5cx divided by 2 raised to power 5. This is the value of P of x if x is equal to 0, 1, 2, 3 or 5. Otherwise, the value of probability will be equal to what? 0. Using this given condition, what we have to prove? P of x less than or equals to 2 is equal to P of x greater than or equal to 3. Already such type of one example we have solved in multiple choice questions. Let us again use the same method to show that these two values are what? Equal. So first we are considering left hand side, that P of x less than or equals to 2. Now check which are the values of random variable which are less than or equal to 2. So less than or equal to 2 means 0, 1 and 2, because 2 is also included. So that's why here we can say that its value is equal to P of 0 plus P of 1 plus P of 2. Isn't it? These are the values of random variable which satisfies this condition, that value of x is either less than 0 or equal to 0, means 0, 1, 2 from the given values of x. So which is equal to, now value of P of x is already given. So just simply we have to replace x by what? 0. So what we'll get here? 5c0 divided by 2 raised to power 5. Now we have to replace x by what? 1. So here we will get 5c1 divided by 2 raised to power 5, and here 5c2 divided by 2 raised to power 5. Just simply we have replaced x by what? 2. So once the values of these 3 probabilities are known to us, simplifying it, we will try to show that its value is equal to what? RHS. And for that purpose we are using one property of combination. In combination, you have studied that NCR can be written as NC. This R can be replaced by N minus R. So this is one of the property which we have proved in case of what? Combination in 11th standard. Now applying this property, let us try to show that value of this left hand side is equals to what? Right hand side. So here, according to this property, phi u c, keep it as it is, means NCR, this R can be replaced by what? N minus R. Instead of R, we are able to write down what? N minus R. N minus R means what we'll get here? Phi minus 0 will be equals to phi. So keep the denominator as it is. All these results we are getting applying this property. Don't disturb to N, just simply R can be replaced by what? N minus R. N minus R. Isn't it? So in the second term, see what we'll get here. If I am applying the same property, phi u c means NC, keep it as it is. This R can be replaced by N minus R. Here N minus R means phi minus 1 will be equals to 4. In the denominator, keep 2 raised to power phi as it is. In the last case also, in the denominator 2 raised to power phi u, keep it as it is. But we are simplifying numerator, applying the same property of combination. So what result we will get? Phi u c. R can be replaced by N minus R, means phi minus 2 will be equal to 3. Now here we can observe that what is the value of X here? X will be equals to phi u. That's why we can say that it is the probability of what? It is the probability for X is equal to phi u. Here what is the value of X? 4. चलो यहाँ पे X की जगह पे यहाँ पे 4 है, इसका मतलब ये किसकी वैल्यू हो गई? P of 4 की वैल्यू हो गई, and this is the value of what? P of 3 according to this definition. And if you'll observe here, observe the values of X. X is what? 3, 4, 5. That's why we can I say that here value of X is greater than or equal to 3. Yes, some values are greater than 3 and here this value is equal to 3. That's why we are saying that X is greater than or equal to 3. Means in this way, considering this left hand side, we have shown that its value is equal to what? Right hand side. And this is the result which we have to prove here. Now see the question number 5. In this question, the probability mass function of a random variable is given to us. Using this, we have to find out value of A and CDF, means cumulative distribution function of X. So first let us try to find out our first required value, that is A. Okay, so using the condition that P of X is probability mass function, this is the given condition. So therefore, if P of X is probability mass function, then what is our result? Sum of all probability will be equals to 1. So summation Pi is equals to 1. How many values of X are given to us? 5. So sum of all their corresponding 5 probability will be equals to 1. Means here we can say that therefore P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 will be equals to 1. Sum of all probability will be equals to 1. So now I am substituting P of 1 is equal to 1 by 20 plus P of 2 is equal to 3 by 20 plus P of 3 is equal to A, P of 4 is equal to 2A, and P of 5 is equal to 1 by 20 is equals to 1. Now collect first terms of A plus 2A is equal to 3A, then collect the numerical value. Check that denominator of first, second and this third term is same. Since denominators are same, so we are taking addition of numerator. See what we'll get. 1 plus 3 is 4, 4 plus 1 is 5. 5 by 20 is equals to 1. So therefore 3A is equals to 1, keep it as it is, plus 5 by 20 on this side will become minus 5 by 20. So which is equal to, if we are taking cross multiplication, 20 minus 5 will be equal to 15 upon 20. So here this implies that A is equals to, if I am dividing both side by 3, so what will get on this side? 3 will get cancelled, we will get A. And if I am dividing to right hand side by 3, so 3 5s are 15, means on this side we will get 5 upon 20. In this way we have got the value of A. In simplest form, value of A can be written as, here we can observe that both the numbers are divisible by 5. So 5 1s are 5 and 5 4s are 20. Means we can say that A is equal to 1 by 4, or we can say that A is equal to 5 by 20. Now, once the value of A is known to us, again we are constructing probability distribution. Already it is given in our example, but with some unknown values are given to us. Now I am replacing A by its value. What is the value of A? 5 by 20. And once the probability distribution is known to us, from that probability distribution, easily we are able to find out what? Cumulative distribution function. In one table, we are representing both the things, probability distribution also and cumulative distribution function also. So value of x are 1, 2, 3, 4, 5. So probability when x is equal to 1 is 1 by 20. It is given to us. For 2, probability is 3 by 20. For 4, probability is A. But what is the value of A? 5 by 20. I am substituting this value 5 by 20 instead of what? 1 by 4 for simplicity, so that calculation part will become easy. Now for 4, what is the probability? 2A. But A is what? 5 by 20. So 2A will be equals to 10 by 20. Just simply I am multiplying to A by what? 2, because P of 4 is 2A. So if I am multiplying by 2, so on this side also multiply by 2. So on this side we will get 10 by 20. And P of 5 is already given in our example 1 by 20. Now we are finding f of x, means cumulative, capital F of x represents what? Cumulative distribution function. So here p of 1 यानी 1 तक के पूरे probabilities की sum. तो इसके आगे तो कोई probability है नहीं, इसका मतलब यहाँ पे 1 by 20 मिलेगा. So when x is equal to 2 means f of 2 is equal to 2 तक के सब probabilities की sum. So कितना मिलेगा हमें? 1 by 20 plus 3 by 20 will be 4 by 20. Again if I am substituting x is equal to 3 here, so what is the probability of all the first 3 probability? 1 plus 3 is 4, 4 plus 5 is 9, 9 by 20. Then take the sum of all the probabilities up to 5. अभी तक यहाँ तक तो 9 by 20 मिला. 9 by 20 plus 10 by 20 will be 19 by 20. And lastly P of x is equal to 5. चलो 4 तक के probability की sum कितनी है? 19 by 20. And 19 by 20 plus 1 by 20 will be 20 by 20. And 20 by 20 will be equals to what? 1. And since the value of f of 5 means for last value of x is equal to 5, if f of 5 will be equals to 1, means we can conclude that sum of all these probabilities 1, means our answer is what? Correct here. In this way, in this table we have taken probability distribution also. Why probability distribution? Because using probability distribution we are able to find out what? CDF. So in this way we have got our next required value, CDF of this random variable x. In this way, from the second part of miscellaneous exercise, we have completed first 5 questions. In the next video, we will start next question, question number 6. A total 15 questions are there. Hardly we will require again 2 or 3 videos to complete this chapter. If you think that these videos are helpful to you, so please like the videos and share these videos with your friends also.